Assalamu alaikum. Welcome to my channel all about chemistry. My name is Sana Alam and this tutorial is all about Lee Chatelier principle, Haber's process, contact process and catalyst. So let's get started. Society, Technology and Science. This topic is taken from your grade 10th book, chapter 9, Chemical Equilibrium, and from page number 15. In this lecture, we will also discuss the term catalyst, Haber process, contact process, and self-assessment 9.1. Okay, so objectives of our class is at the end of this tutorial, students will be able to describe Lee Chatelier's principle, explain importance of Lee Chatelier's principle, define catalyst, Haber process and contact process, and solve self-assessment 9.1. Lee Chatelier, a French chemist, he says that if you induce stress on a system at equilibrium, the equilibrium was shifted so as to relieve that stress. So let's see some example of stress which we can put on a system at equilibrium. Stress can be applied on a chemical reaction by changing concentration, temperature and pressure. Changing in concentration. Concentration can be changed by adding reactants or products of a reaction which is at equilibrium. What does it mean? It means that if you add reactants, the system will start creating more products to reduce concentration of reactants to restore the equilibrium. And if you add product, the backward or a reverse reaction will start occurring at faster rate and reduce concentration of product to restore the equilibrium. Let's see in the picture. In picture A, two equal weight children are balanced. Here the system is at equilibrium. In picture B, equilibrium disturbs. Some weight is added to the boy at the right, which causes the system shift to lower at the right end. Here equilibrium disturbs by adding this stress. In last picture, some of the weight is moved to the left. So then the system is balanced again. Here equilibrium is achieved again. This means that if we put stress on a system at equilibrium, the equilibrium was shifted to relieve that stress. There is one type of stress that we can put on a system. Another stress is changing temperature. Temperature effect on a system is based on a direction of endothermic or exothermic reaction. Students, you are very much familiar to the term endothermic and exothermic reactions. If temperature increases, system will move in the direction which absorbs heat, thus favoring endothermic reactions. If temperature decreases, system will moving in the direction which releases heat and favoring exothermic reactions. Finally, we can also induce stress by applying pressure. Students, you have to keep in your mind that increase in pressure on a system at equilibrium, the forces act to move in the direction with less number of molecules. Okay, here you can see in the picture, this is a pressure pump. We apply pressure on a system. Here we apply pressure on a system. I repeat that increase in pressure on a system at equilibrium, the forces is move in the direction with less number of molecules. For example, in the preparation of ammonia, one molecule of nitrogen gas combines with 3 molecules of hydrogen gas. It will form 2 molecules of NH3, ammonia. Here, number of molecules of reactants are 4, while number of product molecules are 2. So, if we apply pressure, system will create more ammonia, reducing number of molecules. And if you release pressure, backward reaction will be favored. As you can see in the picture, applying pressure resulting in more ammonia, releasing pressure resulting in more reactants. Now I want to discuss with you Haber's process. So what is Haber's process? As I told you in my previous slide that ammonia is produced by a reaction of nitrogen with hydrogen at 400 degrees Celsius, 200 atmospheric pressure, and in the presence of catalyst Fe, iron. This process is known as Haber's process. Okay, here in the preparation of ammonia, we use a temperature 400 degrees Celsius and applying pressure 200 atmosphere. Students, you know very well that H2SO4 sulfuric acid is very common and important acid. There are 3 steps involved in the formation of sulfuric acid. First and third steps are irreversible reactions. So we do not study irreversible reactions here. Second reaction is reversible reaction. So we can discuss only second step here. Second step involves the formation of sulfur trioxide. And this is very important step for the formation of sulfuric acid. Sulfuric acid is produced on a large scale by contact process. In this process, sulfur dioxide is purified and oxidized at 450 degrees Celsius and by applying pressure 200 atm pressure, atmospheric pressure in the presence of catalyst V2O5 called vanadium pentoxide as catalyst. Here I used a term catalyst which I will discuss with you later. Now it's time to discuss importance of Lee-Chatelier's principle. Students, Lee-Chatelier principle has made it possible to get maximum amount of product like sulfur trioxide and ammonia. With the help of this principle, we can yield 98% components of N2 and O2 components of air can be used successfully in producing important chemicals like ammonia and sulfuric acids in 98% yield. Now here I want to discuss with you a term catalyst, which is given on your book, page number 13. A catalyst is a substance which increases the rate of chemical reaction. Catalysts reduce time taken to reach equilibrium, but they have no effect on position of equilibrium once this is reached. Keep in mind that catalysts enhance the rate of reaction. Catalyst never disturbs equilibrium. Now, let's suppose we have a very concentrated solution of sulfuric acid and we want to dilute it. So, what should we do? We add acid to water. Always remember, always add acid to water when diluting it. Why? Because the addition of water to the concentrated acid produces a vigorous reaction which often causes acid droplets to spew in all directions. For this reason, this must be avoided. Now, I want to discuss with you that if we have a reversible reaction like this, and someone says that write its forward and reverse reaction separately. So how to write? Let's take example. We have a reaction. Sulfur dioxide reacts with oxygen in the presence of catalyst in the presence of pressure 200 atm. It will form sulfur trioxide. How to solve this problem? Students, remember that the reaction from left to right is the forward reaction and the reaction from right to left is the reverse reaction. So it is very easy. Solution, we write forward reaction in this pattern. SO2 reacts with oxygen, it will form sulfur trioxide, and if I want to write reverse reaction, so sulfur trioxide decomposes and it will form sulfur dioxide and oxygen. So here I have a very quick recap for you. Today I discussed with you Chatelier principle. Chatelier says that if you impose a change in concentration, temperature or pressure on a system at equilibrium, the system responds in a way that opposes the change. I also discussed with you a term catalyst. Catalyst enhance the rate of reaction. Catalyst never disturbs the rate of reaction. For the dilution, we always add acid to the water. Hope you all have understood the concept very clearly. So thank you so much. It's all about from my side. If you like my video, so please don't forget to like, share and subscribe my channel. Thank you so much. Allah Hafiz.